In a previous module, we covered configuring OSPF within a single area. In this module, we will configure OSPF using multiple areas. We will use the process ID of 20 this time, and we have a backbone area of 0. Anytime you're going from one area, such as area 2, let's say this is this classroom that we're in, and you wish to go over to area 51 over here on another router, we'll say area 51 is the lab, our secret lab there. We must go through area 0 to get to another area. The only way we could go from one area to another directly is if they were both directly connected to a router. If we had area 2 here and area 17 here, this router wouldn't care because it's directly connected. It's only when it has to be routed across to a different network, it must traverse area 0. So if you think about area 2 as this classroom, area 51 is a lab, we'd have to go through the hallway of area 0 to get down to that lab. So we're going to configure OSPF in router 0. Router 1 is already configured for this exercise. Router 0, we're only going to advertise 3 networks: our backbone network, our first LAN, and our second LAN. Go to the PC that's connected with the console cable, go to the desktop tab, the terminal, make sure our settings are correct, which they are by default, and it comes up with the router. We hit enter. User access verification. This is our console password, which if you remember should be Cisco. We are at the user exec mode. We type enable. It's asking us for a password to get to the privilege exec. Oh my, what's the password? Cisco once again, and we are at the privilege exec mode. We want to configure our terminal, so we go config T. Now we want to tell the router we're going to start the OSPF process. So we go router, OSPF, and we're going to use the process ID of 20. I could use whatever I want because it's only of local significance to this router. In router 1 over there, I could have used a process ID of 79. It doesn't matter. Notice the prompt changed to config-router. We are now making a change to the router itself. We advertise our networks, 148.10.10.0. I'm going to use the inverse mask or the wildcard mask, 0.0.0.7, and we're going to leave this guy in area 0. Because that way when we see something in area 0, which is the same as the backbone, it will only show up as an O for OSPF in the routing table when we go show IP route. When I add something in with a different area, it's going to show up with an OIA for inter-area. Now I'm going to add my next network in. I'm going to do that simply by hitting up arrow. I'm going to change the area to area 2. I'm going to go over here and change the 10.0 address to the 10.8. Now I want to add in my backbone. 148.20.20.0 with the wildcard mask or inverse mask of 0.0.0.3, and our backbone must be in area 0. As soon as I enter this, it's going to go out and try and establish an adjacency with router 1. And because I have the same area number, it's going to come up and it's going to have no problem. See this message up here where it says line protocol 5 up down right here? A 5 is a good status. A 4 is a bad status. So when we start off OSPF, we want to be able to see an OSPF state of 5 in that message. If we saw a 4, that would be a bad message. It would tell you we have an area ID mismatch, and the message would tell you that as well. So we hit enter, and right here we're going to go out and we got OSPF 5. There we go. Adjacency change. Our process ID of 20. The number it learned is the 148.20.20.2. That is the IP address of the serial port over on router 1. We learned about it on our serial port. Went from loading full to loading done. So right now this router has established a full adjacency. It's learning about the networks over there that router 1 has in its routing table, and it's sharing information about our 2 LANs. Being that we are in the global mode, I could not simply do a show run or a show IP route or a copy run start. I have to add the word do and append that command to tell it to do something that it's not normally going to do. If I just tried to go show run right now, it's going to tell me, hey, invalid input detected at that marker. So we add do show run, and it's going to say, oh, okay, I can handle that. Hit space bar, Notice we see our OSPF statement in there, logging any adjacency changes, whether links up or down, and our 3 networks, 2 of which in area 0, and 1 which is area 2. Now I want to go do, copy, run, start. Enter. Now I'm going to press Control Z just to get back to the regular privileged exec mode, and I'm going to go show IP route. This is our routing table. We see our 2 directly connected LANs right here. Notice that our fast Ethernet 01, the .8 network, we know that that's in area 2. Our router doesn't care because it's directly connected. It learned about the 148.10.10.16, which is this area right here. It's area 0, so it just has a standard O for OSPF right up here. We have an OIA for this network here, area 51, and the IA stands for OSPF inter-area. And we have our connected backbone link. I'm going to close this down. We're going to go to the command prompt, and we're going to ping one of the PCs over there. So we type in ping 148.10.10, and we're going to go with 27, which should be the address for PC number 6. Now when I do this, we should see, the first time we should see 2 timeouts, because number 1, our switch over here has to learn about our MAC address and add it to its MAC address table. We'll cover more of that when we get into the switching exercises. And the switch over here, switch number 3, has got to learn about this MAC address. So we should see 2 timeouts the first time through before we get a successful response for a ping. The next time we ping, we'll get 4 successful pings. Oh, here we got it with 1. Hey, no problem. We hit the up arrow to ping it again, and we're going to get 4 replies right away. I'm going to close this down. We're going to go back into our router. One other thing is when we're in and programming OSPF, get back in there, router OSPF 20. If we had information about, I'm going to drag this over, a static route going up to the internet service provider or a default route, we would want to make sure that we make that information about that other router known over to router 1. We do that by typing in the command default-information originate. And what that will do is that will push any information about a default route over to any subsequent router behind us. Therefore, you don't have to try and share that network because you don't own that network going up to the ISP because you don't own the ISP router. So once again, we're going to go do, copy, run, start, enter, and this exercise is done.